Hello students, today we'll be discussing about the JEE mains paper that was conducted in 2017. So here onwards we'll be discussing all the 30 questions one by one, the concepts and the tricks to solve the questions of JEE 2017 mains physics paper. Okay. Let us move to next question. Question number 12. The question says a particle is executing simple harmonic motion with a time period t, a time t equals to 0, is at its position of equilibrium. So let us understand the situation first. Suppose this is the mean position. These are the two extreme positions. This is called extreme right and this is called extreme left positions. Okay. Now the body starts its motion at time t equals to 0. It starts from here. This is given in the question. At time t equals to 0, it is at its equilibrium position. So I can write alpha equals to 0. Alpha is the initial phase because it starts from here, then alpha equals to 0. And which side is going is not given. It might be going towards right or towards left. Then the equation will change, but that will be changed only in terms of minus sign. So it is nothing to do much with the kinetic energy because the question is about the kinetic energy and the kinetic energy is always positive. So it is at its position of equilibrium, the kinetic energy time versus graph will look like. So that means you have to write the relations between kinetic energy and time t. If you are able to find the relations, then only you can plot the graph. So I will say that what is the continuous curve that you'll get? The body will move to the point here. Let me draw this. The body will first start move from here to this point. Then it will come back to this point. Then go to the other side of the mean position. This is the extreme left position. From here it turns back and comes out to this position. This is one time period. So the graph is to be drawn for one time period, and let us check which graph is probably matching with the nature of each curve is same. You can see it is same, but then this difference is in the t values that we have to look for. Anyway, first of all, I'll just help you get the equation, then I'll just tell you how the answer is done. First of all, we know that if a body starts its motion from mean position at alpha equals to 0 mean position, then the x equation is the displacement equation of SHM is given by a equals to a sine omega t, because alpha part is 0. So this is the case, and if I differentiate this one derivative dot, this is a omega cos omega t, a omega cos omega t. This x dot is your velocity. The velocity is a omega cos omega t. Now what is kinetic energy? Suppose that any time it is here, this is the velocity, and the kinetic energy at any instant is given by half m this v square. If I square it, then I'll get half m. This is a square omega square cos square omega t. So kinetic energy is like this. So you can see that this number half mass, the amplitude of oscillation, and omega is constant irrespective of the position of the particle. So this is a constant. So this is kinetic energy something, some constant into cos square theta. That means what is the graph of y equals to some constant or only one. Suppose the constant is also 1 cos square theta. What is the nature of this curve? Y equals to cos square theta or cos square t. The graph of cos theta is like this. This is the graph of y equals to cos theta. Then the graph of cos square theta is something like this. This is the graph of y equals to cos square theta. Then you can see that from here 1 2, so here and here, this is the frequency here is doubled. In the same time period, the frequency is doubled. You can see here. If this completes one oscillation here, you can see this cos theta completes one oscillation here, but here it completes 2 oscillations. The frequency of cos square graph is double that of this. So the graph is like this, but then where to choose is the method will be like this. Then how to choose which one is the correct answer? Now the thing is that I'll just tell you that from mean position, from here mean position to this position, it will take time t by 4. That we must know, that from here it will take t by 4, then come back to this again, from here to here again it will take t by 4, so t by 4 again t by 4, so returning limit also it will take t by 4 to the mean position, the mean to this extreme again it will take t by 4, then from here to here again it will take t by 4. So this is how the time is divided. That means you to that also see which one is correct in terms of t by 4, t by 4, t by 4, t by 4. And we also know that from here the velocity is 0 here, so the kinetic energy is 0 here, so 0 at every t by 4. So at t by 4 the kinetic energy should be 0. So you can see here, if you look at this graph, after t by 4 the kinetic energy is 0, the particle is at rest here momentarily. So this is correct. Then but here it is 0, but after time t by 2, but after time t by 2 it is not 0, it is maximum. So you can see here it is maximum. Okay, then again after t by 4, that is 3t by 4, again next t by 4 it should be 0. It's correct, it is 0. Then again it should be maximum, so again it is maximum. So this graph is correct graph. So this is the right options, because if you see this also looks like that, but the problem with this graph or this graph is that it says that initially it is 0, but initially it's not 0. So this is not possible, because initially the velocity is maximum, and that is equal to omega a. That is the maximum velocity when it is in mean position. So it is never 0. So this graph is not possible. This graph is not possible. So out of these two graphs, you have to choose. Then we know that if it is maximum, and then when it becomes 0, after what time it becomes 0, what time it touches the time axis, then it is obviously t by 4. So it is not t by 2. It should be t by 4. Okay. So after t by 4 again it will be maximum, again t by 4 is 0, again t by 4, so it is just like that. So after t by 4 it is happening like this. So the correct answer is 4. Okay, thank you.